Hi all, we're starting with the ATP-PC system. This is the first of our anaerobic energy systems. Okay, so all that means is the energy sources that I'm breaking down to resynthesize ATP do not require oxygen to take place. Okay, so the first thing you need to know about the ATP-PC system is about how long it provides energy for. Okay, so you need to know that the ATP-PC system will last for up to 8 seconds. Okay, so its actual time it provides energy for is 8 seconds. Now, when you get given a question, which I'll show you in a bit, right, it might ask about the majority of energy being provided. Okay, now you just have to think if it provides energy for 8 seconds, okay, if the event was to go on for 9 seconds and 10 seconds, right, it would still be providing the majority of the energy, okay, because it's provided energy for 8 seconds, and let's say we're in a 10-second race, then 2 seconds would have come from somewhere else. So any kind of event that is lasting up to 15 seconds, all right, the majority of energy is being provided by the ATP-PC system. Okay, so look here. 0 seconds, it lasts up to 8 seconds. If the event lasted 15 seconds, then it would provide energy for 8 of it, which means another energy system would be providing it for 7 seconds, which means that would be the majority. Okay, now we need to have a look at the process of what happens when I do that. So on here, let's just remind ourselves of how we provide energy. So first of all, we've got this ATP splitting. So remember, ATP is broken down by ATPase. Sorry, it's not very neat on here. So it's broken down by ATPase into ADP plus P plus energy. And remember, that energy was used for muscular contraction so that I can move. However, I only kind of have enough ATP to last for 2 seconds of exercise. So once that's gone, right? And remember our exam tip, the only way you can move is by breaking down ATP. Okay, which brings us to here. So this is in my muscle now. So let's say I've broken down all my ATP into ADP plus P plus energy. Now we're missing energy now because I've used it for the muscular contraction. So all I've got left in the muscle is ADP and P. Now that's an issue because now I've no ATP to break down. So what have I got to do? I've got to resynthesize it. Now the way that takes place is I have something important, all right, here, is called creatine kinase. Okay, creatine kinase has 2 jobs, right? Its first one is to detect high levels of ADP in the muscle. So basically it notices that you've broken down a lot of ATP. Okay, so it detects, first of all, high levels of ADP in the muscle. So what it does then is it breaks down this PC, okay? It breaks down PC into P plus C plus energy. Okay, now this energy isn't used for muscular contractions. It's got a different job. Okay, so this energy is going to be used over here, okay, and it's going to help to stick back together the ADP and this P that's just chilling in the muscle right now. Okay, so let me just run through this one more time. First of all, I've got ATP broken down by ATPase into ADP plus P plus energy. That's fine because now I can perform muscular contractions. However, now I've got loads of ADP and P in the muscle, okay, which means I can't provide energy for muscular contractions. So creatine kinase first detects high levels of ADP in the muscle. So what it does is it breaks down PC into P plus C plus energy. Okay, this energy is used to resynthesize ATP through this ADP plus P. Okay, so this energy is sticking back ADP and P together, okay, to form ATP again. Okay, if you were to do it like this, adenosine, I've got a phosphate here, I've got a phosphate there, there's ADP, okay, then I've got a phosphate there, okay. This energy is used to do this, and it becomes ATP again. Now, I go back to here. So when we're talking about this in an exam answer, you firstly need to talk about this creatine kinase stuff. Then you need to talk about the breakdown of ATP again. Okay, so it would pretty much start here. Okay, however, we need to remember where that started from. So your exam answer would sound like this: is during X movement, okay, creatine kinase will detect high levels of ADP. Okay, so it breaks down PC into P plus C plus energy. This energy is used to resynthesize ATP through ADP plus P plus energy. Okay, now ATP can be broken down by ATPase into ADP plus P plus energy, and now I can perform muscular contractions once again. Hopefully that makes sense to you, which takes us kind of into the questions, and I'll do another video in terms of the evaluation. So a question might look like this, okay? So a sprint cycling race involves 4 laps of a 250 metre track. The last lap is completed in 10 to 12 seconds. That's important. Name the main energy system being used in the final sprint and explain how it provides energy. Okay, so the first thing we need to do is name the main energy system being used. Now, to work that out, I've got to look at the time frame. Now, it says 10 to 12 seconds. Now, in your head, you should be thinking, right, it says main energy system. So what's providing the majority of the energy? So the ATP-PC system can provide it for up to 8 seconds of that. Okay, let's say it provides it for the 8 and it's a 12-second lap. It would still be the majority because another energy system would only have to provide energy for 4 seconds. Okay, so we would firstly say the majority of energy is provided by the ATP-PC system. Okay, this occurs through, firstly, creatine kinase detects high levels of ADP in the muscle. Therefore, it breaks down PC into P plus C plus energy. This energy is used to resynthesize ATP through ADP, P plus the energy. Now, ATP can be broken down by ATPase into ADP plus P plus energy, and this energy can be used for muscular contractions. These muscular contractions, you could even put allowing the performer to pedal faster during